For centuries, Saturn has been one of the most mysterious objects in the night sky. Its enormous rings have fascinated astronomers, while its distant moons have raised questions about how worlds can form and evolve so far from the Sun. But when the Cassini spacecraft began its mission, scientists were about to see Saturn in a way no previous generation had ever experienced. Launched in 1997, Cassini spent almost 7 years traveling through deep space before reaching Saturn in 2004. The spacecraft was originally planned for a much shorter mission, but its discoveries were so valuable that the mission continued for years. During that time, Cassini transformed our understanding of the Saturn system. It photographed enormous storms moving through Saturn's atmosphere. It studied the planet's complex magnetic environment and examined the countless structures within its rings. But some of the most exciting discoveries came from Saturn's moons. One moon in particular captured the attention of scientists, Enceladus. At first glance, Enceladus looked like a small, frozen world. But Cassini discovered enormous plumes erupting from its surface, sending water vapor and icy particles into space. The discovery was extraordinary. It suggested that beneath the moon's frozen exterior could be a hidden reservoir of liquid water. Scientists also detected organic compounds within material associated with the plumes. Organic molecules are not proof of life, but their presence makes Enceladus an especially interesting place for future research. The discovery changed the scientific conversation around Saturn. Instead of thinking of the outer solar system as a collection of frozen, inactive worlds, researchers began considering the possibility that some icy moons could contain environments capable of supporting interesting chemistry. Cassini also revealed how complicated Saturn's rings really are. From Earth, the rings can look like smooth bands surrounding the planet. Up close, however, they contain countless gaps, waves, particles, and gravitational structures. The rings are constantly interacting with Saturn's moons. Gravity can pull particles into unusual patterns, create divisions, and generate waves that move through the ring material. This makes Saturn's ring system an enormous natural laboratory for studying gravity and orbital dynamics. As Cassini continued its mission, scientists became increasingly interested in what was happening in the regions between the planet and its rings. The spacecraft's instruments could measure magnetic fields, particles, plasma, and other properties that cannot be observed simply by looking at Saturn through a telescope. Occasionally, unusual measurements can appear. But this is where scientific caution becomes essential. An unexplained signal does not automatically mean an artificial object. Spacecraft instruments can encounter unexpected physical processes, temporary disturbances, radiation effects, or limitations in measurement. A strange observation is valuable precisely because it gives researchers something new to investigate. That distinction becomes particularly important when discussing claims of mysterious structures or possible extraterrestrial technology around Saturn. The original source describes alleged geometric objects, unusual gravitational behavior, and signals interpreted by some as evidence of artificial activity. However, those interpretations remain speculative and are not established discoveries from the Cassini mission. What Cassini did unquestionably discover was already extraordinary enough. It revealed that Saturn is an active and complicated system, filled with dynamic weather, intricate rings, unusual magnetic behavior, and moons that may contain hidden oceans. And then came the spacecraft's most dramatic phase. Near the end of its mission, Cassini began a series of daring orbits that carried it into the narrow region between Saturn and its innermost ring. No spacecraft had explored that area so closely before. The mission team knew the spacecraft would eventually be destroyed. But before that happened, Cassini would collect some of its most valuable measurements. And as it moved deeper into the Saturn system, scientists prepared to learn more about the planet's atmosphere, magnetic field, rings, and mysterious surroundings than ever before. Cassini's final journey around Saturn was unlike anything the spacecraft had attempted before. Instead of remaining safely outside the planet's rings, it repeatedly passed through the narrow gap between Saturn and the innermost ring. The maneuver was extremely challenging. The spacecraft was moving through a region filled with particles and powerful gravitational forces, while its instruments continued collecting measurements. Cassini's final orbits gave scientists an unprecedented opportunity to study Saturn from extremely close range. Its instruments examined the planet's atmosphere and magnetic environment while recording information about the material surrounding it. These observations helped scientists improve their understanding of Saturn's internal structure and the relationship between the planet and its rings. Eventually, however, Cassini's mission had to come to an end. Engineers deliberately directed the spacecraft toward Saturn's atmosphere. The decision was made to prevent Cassini from accidentally contaminating potentially interesting moons such as Enceladus or Titan. As the spacecraft descended, its instruments continued transmitting information back to Earth. Then Saturn's atmosphere became too dense. Friction increased. The spacecraft began losing its ability to maintain stability. Eventually, Cassini was destroyed. Its final transmission marked the end of one of the most ambitious planetary missions ever attempted. But its scientific legacy continues. The mission left scientists with enormous amounts of information about Saturn, its rings, and its moons. Perhaps the most important discoveries concern the possibility of habitable environments beyond Earth. Enceladus became one of the leading locations in the solar system for investigating the possibility of life beyond our planet. Its underground ocean, water-rich plumes, and organic chemistry make it an extraordinary target for future missions. Titan is equally fascinating. Its thick atmosphere contains complex organic chemistry, while lakes and seas of liquid methane and ethane exist on its surface. It is a world unlike Earth, yet it demonstrates how different forms of planetary chemistry can operate. These discoveries show why Saturn remains such an important destination. The more we investigate it, the more complicated the system becomes. The original source also describes claims of artificial structures, unexplained gravitational signals, mysterious particles, and possible extraterrestrial installations. These ideas make for fascinating speculation, but they should not be confused with confirmed Cassini discoveries. There is currently no established scientific evidence that Cassini photographed an alien spacecraft, discovered an artificial base inside Saturn's rings, or detected a deliberate extraterrestrial communication. That does not make Saturn boring. Quite the opposite. The real discoveries are already astonishing. A tiny icy moon can release water into space. A world farther from the Sun can contain complex organic chemistry. A planetary ring system can behave like a giant laboratory governed by gravity. And a spacecraft launched from Earth can travel billions of kilometers and send back information that changes our understanding of distant worlds. Cassini also demonstrated something important about exploration. Sometimes the greatest discoveries come from places where scientists were not expecting them. A mission designed to study Saturn became a major investigation into oceans beneath alien ice, unusual atmospheric chemistry, planetary rings, and the conditions that might allow life to exist beyond Earth. Its journey may be over, but the questions remain. Could Enceladus support microbial life? How did Saturn's rings form? What lies beneath the surfaces of its moons? How common are hidden oceans throughout the outer solar system? And are there other worlds where chemistry has progressed toward biology? Those questions will require future spacecraft, better instruments, and years of careful research. Cassini did not prove that aliens are hiding around Saturn. What it did prove is something perhaps even more important. The outer solar system is far stranger and more active than we once imagined. And every time humanity sends a spacecraft into the darkness, The universe seems to give us another reason to keep looking.